Welcome back. In this video we are going to discuss about three topics. First, triple integration in the rectangular coordinate. Second, triple integration in the cylindrical coordinate. And third, triple integration in the spherical coordinate. So let us see first triple integration in the rectangular coordinate, and it is very quite easy as we have seen in the double integration. So triple integration of the continuous function f of xyz over the region V can be evaluated by the three successive integrations. The triple integration of f of xyz over the region V is denoted by triple integration over V f of xyz dv. So let us see first question. It is very quite easy, but it should be understand that what should be the first limit, then after what can be assumed that, and then after what. So first we will keep in mind that whatever we have, instead of that sometimes they may ask as a dv. So in that case you have to decide that what we have to do first, integration with respect to x, y or z. So here yz are given, that means it cannot be considered for the limit for y and z. So instead of that I am just going to consider it is limit for x is equal, that is 0 to yz. So x is over, so I have to just concentrate on y and that is z. So this is what exactly in this case we can see that 1 to z is there, so it is not considered for the limit for z. So instead of that I have to consider this limit for y is equal 1 to z, and then after I will consider the remaining x, y and z. So z is equal, that is 0 to 2. So in that case it will be very easy to integrate with respect to first x, then after we will do it with respect to y, and then after we will do integration with respect to x. So let us see first. So this is also whenever you have given that like this one, so first integration is with respect to x, so this is limit for x, after that integration with respect to y, and then after with respect to z. But not always this sequence will be followed by the examiner. Sometimes they may ask dy, dx, dz, or they may ask simple, that is the dv. So in such cases you have to decide that what should be the first limit with respect to x, y or z. So let us see solution of this question. So first limit is for x. So when I integrate with respect to x, so what I will get, yz as a constant. So integration of x with respect to x is nothing but x square by 2. But when you put the upper limit first, so what I will get, y square z square minus 0, but divide by 2 is there, so 1 by 2 is a constant quantity. And when I multiply, so what I will get, y raised to cube into z raised to cube. But again I want integration with respect to y, so z raised to cube is nothing but constant quantity when we do the integration with respect to y. So I just taken outside from this integration, but now when I integrate with respect to y, so what I will get, y raised to 4 divided by 4 from y to where, that is 1 to z. But when we put the first upper limit, so what I will get, z raised to 4, but 4 is the constant quantity, so you can take outside this integration, so 4 to z, that is 8. So 1 by 8 is there, integration that is 0 to that, z raised to cube is there. Z raised to 4 and y is equal 1, so I will get only 1. So this is z raised to 4 minus 1 dz. But now it is very clear that z raised to 5, z raised to 7 is there, but when we integrate with respect to z, so z raised to 8 divided by 8 minus z raised to cube is there, but when we integrate with respect to z, so z raised to 4 divided by 4 from y to where, that is 0 to 2. But when you put the upper limit and simplify, so you will get 32 minus 8 divided by 8, and that is what, 28 divided by 8. So you will get 7 divided by 2, and that will be the final. So now triple integration in the cylindrical coordinates. So you might be curious that how we can determine these cylindrical coordinates. So it is clear that when we draw the circle on the xy plane, so it is like that. But when it traces along the z axis, so it is exactly look like the cylinder. That means whenever we see it's a cylindrical coordinate, so what I can say, so x is equal, that is r cos theta, and y is equal, that is r sin theta, when we use the only xy plane. But it is traced along the z axis, so I say z is equal z. So for xyz, that Cartesian coordinate transforming to the cylindrical coordinate, that is x and y in terms of r and theta, so I say r theta, and z in terms of z, so I write that is z. So it is quite clear that x, y, z is same as the r, theta and z when we use the Cartesian coordinate to the cylindrical coordinate. So our triple integration f of xyz dx dy dz will be triple integration f of r cos theta, that is x, y is equal r sin theta, z is equal z, and this is a Jacobian because we are transforming xy to the, because we are focusing only xy to the only r theta, because z is z, that is the same, and therefore the Jacobian j will be the on the r, and then dz dr d theta. So first we will do integration with respect to z, then r, and then the theta. So also you can assume that that is the Jacobian j, and also it will be the same. So when you assume that this one Jacobian, so simply we will keep in mind that we are going to transform x, y, z to the r, theta and z. So you can write what you can say, this is x, r, x, theta, x, z, y, r, y, theta, y, z, and z, r, z, theta, z, z. So whenever you simplify, so definitely you will get that is the r, and that will be the same. So therefore, finally, triple integration f of xyz dx dy dz, that can be written as triple integration f of r cos theta, r sin theta, z, mod z is nothing but r, dr, dz, dr, and then d theta, and that will be the cylindrical coordinate when we that will be the triple integration when we use the cylindrical coordinates. Let us see the question number 1. Integration, that is 0 to 2 pi, then 0 to square root of z, and then 0 to 1, and this is our function r d theta dr dz. But first integration is with respect to theta, so we will first focus on that. So this is our given question, so I just write r as a here. So first with respect to theta, so I'm just going to focus, but when we use the cos for theta, but cos for theta is nothing but 1 plus cos 2 theta divided by 2. But here you can see that r square by 2 is the common, and integration with respect to theta, so what you are going to get, that is the theta, then integration of the cos 2 theta, that is sin 2 theta divided by 2 plus z square theta over backward, that is 0 to 2 pi. But here it is r is there, but what I'm just going to take r into r square, that is the r raised to cube divided by 2. But when I put theta is equal to pi, so this is the 2 pi, and sin 4 pi, since sin 4 pi is nothing but 0. Again 2 pi will be there, because theta is nothing but 2 pi, so I can take 2 pi common, so I will get r raised to cube divided by 2 plus r multiply with this one also, so I can say z square r and then d theta dr, then dr dz. But when I integrate with respect to z r, so what I will get, r raised to 4 divided by 8 plus z square into r square divided by 2 over 0 to square root of z and then dz. But when you put first r is equal, that is square root of z, so you will get that is z square divided by 8 plus square root of z raised to power 2, so it will be the z, and you will get z into z, that is z raised to cube divided by 2 dz. But when you integrate with respect to z, so you will get z cube divided by 24 plus z raised to 4 divided by 8 over backward, that is 0 to 1. But when you put the upper limit and then after the lower limit, so you will get, after taking the LCM, you will get the answer, that is the pi by 3. Let us see another question. Triple integration over the region R. This is square root of x square plus y square dv, where R is a solid bounded by the surface x square plus y square is equal z square, z is equal 0 and z is equal 1. So it is clear that whenever you see this kind of, so this is x axis, y and z. When I consider this region, so x square plus y square is equal 0, so it will be like here. But x square plus y square is equal, that is 1. So height z is equal 1 if I take this one. So it will be what? Here x square plus y square is equal 1, like that. And again you may assume that here. So when you join all these points, so what you are just going to get this one, and the same is for the below side. But we are going to interested from the z is equal 0 to z is equal 1. So this is our z is equal 1 plane. So now it is very easy you have to just consider that the only coordinates, which kind of coordinates you are going to just assume that the cylindrical coordinates, because exactly it is one of the part of the what exactly you can assume that this is our cylinder. So it is a part of what exactly cylinder. So your x is equal r cos theta, y is equal r sin theta, and z is nothing but only z. So these are the cylindrical coordinates. But we have the square root of x square plus y square. So in that case, x is equal r cos theta and y is equal r sin theta is replaced. So in that case, you will get r. So dv can be written as what? Dx, dy, dz. But dx, dy is nothing but r. And then dr or d theta is there, and dz is that is the same, there is no change. But now you need to focus on the limit. So how we can determine the limits? So whenever you see only this one region, because we needed to consider only this one region only. So when I draw the line which are parallel to z axis, so this is the line and this is what part of this. So I can say this is x square plus y square is equal z square. So z is equal plus or minus square root of x square plus y square, but it is on the upper part. So I will assume that only plus quantity. So bottom is nothing but this one and top is what? So I can say when I put the z is equal 1, so it will be the x square plus y square is equal 1. So I can say z is nothing but only 1. But now this is the limit, and it is clear that x square plus y square is nothing but r square. So limit for z will be the r to 1 and theta, because ultimately top part is what exactly our circle, but when we take the projects from the xy plane, so it is a circle. So we have to rotate theta is equal, that is 0 to 2 pi, and radius is what? So it is clear that one radius circle, because when we take the projections, so what you are just going to get this one. So this is one radius circle. So when we put all these limits in this integration, so triple integration over the region R, this is R, and this is what exactly r, dz, dr, d theta. So from this it is clear that this limit cannot be r. So instead of that, I am just going to consider that is the z is equal, that is the r to 1, then r is equal, that is 0 to 1, and then after theta is equal 0 to 2 pi. So corresponding that we first integrate, so I will get only z over y to r, that is r to 1. But when I put first upper and then lower, so 1 minus r is there, but now just multiply with this one, so you will get this one. But when you integrate with respect to r, so r raised to cube divided by 3 minus r raised to 4 divided by 4 over y to r, that is 0 to 1. But when you put first upper and then lower, so you will get, that is the 1 by 3 minus 1 by 4, so you will get 1 divided by 12. And now just integrate with respect to theta, so you will get only this one, 1 divided by 12 multiply by 2 pi, so you will get, that is the pi by 6. Now let us see the triple integration in the spherical coordinates. So first, spherical coordinate, that is r, theta and phi, are used to evaluate the integral in the region which are bounded by the sphere at the center at the origin. So here the Cartesian coordinate x, y, z, and we will transform to the spherical coordinate, that is r, theta and z. But what is exactly spherical coordinate? That is x is equal something, y is equal something, z is equal something. So x is equal r sin theta cos phi, y is equal r sin theta sin phi, and z is equal, that is the r cos theta. Then our triple integration becomes, but in that case you should keep in mind that what should be the rotation for the theta and what should be the rotation for the phi. It is a rotation for the phi angle, that is 0 to 2 pi, and when we observe that angle theta, so it should be rotation from y to r, that is 0 to pi. So that thing we will keep in mind. Triple integration, x is replaced by r cos theta cos phi, y is equal r sin theta sin phi, and z is equal r cos theta. And Jacobian j, so Jacobian j will be what? So xy is that transforming to the r, theta and phi, so we can write, and in that case you will determine, that is r squared sin theta, dr, d theta and d phi. So our triple integration becomes like this one. How we can get the spherical coordinates? But question arises that how we can say this one. Now from the figure, it is clear that when the angle theta is rotate from where to where. So try to understand it is z axis to bottom. So that means theta is rotate from that is 0 to pi. But when you consider only angle that is phi, so that phi is what exactly? It is going to be the circle. So it is exactly circle. So I can say that is 0 to 2 pi. And then after we can get the circle. Again try to understand what the figure says, how we can get the circle. So this is our angle phi that you can see, and from that we have to rotate from that is 0 to 2 pi, and angle theta is what that you can see along the z axis. It is going to be blue color line, so it is rotate from here to that is only this one. So therefore theta is nothing but that is 0 to pi. And whatever you have given that the radius, that we can consider, if suppose that the radius is nothing but a, so we will consider that is 0 to a. This is the spherical coordinate, that is x is equal r sin theta cos phi, y is equal r sin theta sin phi, z is equal r cos theta. So in that case limit will be this one. If we have the spherical coordinate with x square plus y square plus z square is equal a square. But when we talk about the hemisphere, so in that case what? Hemisphere is what exactly? Half of this sphere. So in that case x is equal, that is the r sin theta cos phi, y is equal r sin theta sin phi, and z is equal, that is the r cos theta. So in that case circle is there, that means phi is rotate from where to where, so that is 0 to 2 pi. But theta, that will be what? In that case we have to half, that means we have to cover up to here, not below side. That means theta will be that is 0 to pi, and that is what exactly our hemisphere. So whenever we have the first octant, so in that case x is equal whatever we have, that is the r sin theta cos phi, y is equal r sin theta sin phi, and z is equal, that is the r cos theta. So in that case what should be the angle? So in that case we have to consider theta is equal 0 to pi by 2, and also phi will be that is 0 to pi by 2, and that thing we will always keep in mind. So these are the first spherical coordinate. Then we have discussed about the hemisphere. So first octant will be, this is our xyz. So in that case theta is rotate from 0 to pi by 2, and phi also rotate from 0 to pi by 2. So let us see first this question. This question says we want to evaluate triple integration, but it is clear that when we look at the graph, so in that case what I can say, this is x-axis, y-axis and z-axis. So it is right half part of this figure. That means I'm just going to focus only this one region. But you should understand with geometrical approach with the 3 dimension. So it will be very clear which part of the circle it is going to be covered. That is very important. So here we are just going to consider the spherical form. Spherical coordinates are there, but the reason of integration is the positive octant of the plane, because we are given that this one limit 0 to infinite, 0 to infinite, 0 to infinite. That means we are focusing on the positive octant of the plane. So in that case limit for r, that will be that is 0 to infinite. So what will be the angle theta, that will be 0 to pi by 2, as well as phi will be that is 0 to pi by 2. So therefore the triple integration becomes, this integration becomes theta is equal, that is 0 to pi by 2, phi is equal, that is 0 to pi by 2, r is equal, that is 0 to infinite. But x square plus y square plus z square is what? Exactly r square. R square sin phi, that is our transformation, because x dx dy dz is equal Jacobian j dr d theta and d phi. But Jacobian j is what? That is the r square sin theta dr d theta and then d phi. So when you integrate with respect to first theta r, then theta and then phi, because all you can take here, now you have to integrate with respect to r, theta and z. phi. So in that case, r square divided by 1 plus r square raised to power 2. So this is for integration with respect to theta. Then you can write separately because there is no terms of phi and theta. So you can do integration separately. Then we have phi. So sin phi, sin theta is there from y to y, that is 0 to pi by 2 d theta. Also you can integrate with respect to theta, and then phi. But when you see this integration, so I have to assume that r is equal, that is tan t. So dr is equal sec square t dt, and r is equal, that is 0. So what I can say, t is equal 0. But when I want r is equal, that is infinite, so t should be what, exactly pi by 2. So a new limit will be what, 0 to pi by 2, and r square is nothing but tan square t, and 1 plus r square. So 1 plus tan square, that is the sec square raised to power 2, so sec raised to 4, and dr is nothing but sec square t dt, and this is the same, that also you can integrate with respect to theta, and then phi. So let us see. But that also you can simplify. Tan square can be written as sec square t divided by cos square t, and sec square t will be eliminated, so 1 sec square t is there, and then dt. So what you can see, so these are the inverse of each other, so it will be the what, only 1. So you will get integration, that is 0 to pi by 2 sec square t dt. Then integration of the sign is what, exactly minus cos theta over 0 to pi by 2, and phi over 0 to pi by 2. But when you consider this one, sec square t is equal what, exactly 1 minus cos 2t divided by 2, and then after you may write the upper limit, so cos minus cos pi by 2 plus cos 0, and then pi by 2. But when you first integrate and when you simplify, so this is what, exactly our pi by 2. But when you integrate with respect to t, and when we put t is equal first pi by 2, and then after t is equal 0, so you will get 1 by 2 is there, pi by 2 into pi by 2, so that will be the pi square by 8. So in this video we have discussed about the three main topic and the volume, triple integration with the help of the rectangular coordinate, cylindrical coordinate, and spherical coordinate. Thank you.